Figure 22 shows two identical springs supporting an object. Three short lengths of cord are tied together at point X. The other ends of the cords are attached to the ends of the springs and the objects as shown in figure 22. The angle between the central axes of the springs is 90 degrees. The tension in each spring is the same and equal to T. The weight W of the object is 4.8 newtons. The point X is in equilibrium. So for part A, we've got to state and explain the magnitude and direction of the resultant force at X due to the two forces exerted by the extended springs. So the magnitude is going to be equal to the weight, which is 4.8 newtons, and the direction is going to be vertically upwards. And the reason for that is that the resultant of the two springs must be equal and opposite to the weight. So we've got to sketch a labelled triangle of forces diagram. For the three forces acting at point X, you do not need to draw the diagram to scale. So if I just draw the forces on as a free body diagram, and then if I transpose those forces, so there's going to be my weight, that's going to be one of the tensions, there's going to be the third tension, put my angles in, 45 degrees there, the right angle between the two. What I haven't done is I forgot to label them, so I probably would put the W in and the T and the T. So here we've got to show that the tension T in each spring is around about 3.4 newtons. So the weight is 4.8 newtons and we've got a right angle triangle. So I can say that T squared plus T squared is 4.8 squared. So 2T squared equals 4.8 squared. T squared is going to equal 4.8 squared over 2, so T is going to be the square root of 4.8 squared over 2, which indeed comes out as being 3.39 or around about 3.4. So the force constant of each spring is 24 newtons per metre, and we've got to calculate the energy stored in each spring. Okay, so the work done, or the energy stored, is going to be a half kx squared, but we don't know x, so if I use F equals kx and rearrange, I get x equals F over k, and then I can substitute that back in, so that gives me k, F squared over k squared over 2, which equals F squared over 2k, and now if I substitute my 3.4 squared in over 2 times 24, then the answer comes out as being 0.24 joules.